Two monos meet, chemistry happens, and boom, a disaccharide is born. Hi everyone, I welcome you all to the another lecture of this series. Today we will be understanding about disaccharides. So disaccharides, as we already know, such as maltose, lactose, sucrose, they contains two monosaccharide units which are joined together covalently by an O-glycosidic bond. So this O-glycosidic bond is formed when a hydroxyl group of one sugar molecule reacts with the another, all right, with the another anomeric carbon atom of another sugar. So let us understand. Moving on to the maltose, we'll be starting from the maltose, which is a disaccharide, and this maltose, this contains two D-glucose residues here, and together they are joined by the glycosidic linkage. Here you can see this glycosidic linkage. This is alpha. Why this is alpha? Because the first glucose molecule involved is in alpha configuration. So this kind of bonding is alpha 1,4 linkage. Here you can see a bond is formed between the anomeric carbon atom number of the first glucose and the fourth carbon atom of the another glucose molecule. So it is the alpha 1,4 linkage. All right. So, when the maltose is formed, so this is a disaccharide and it has a free anomeric carbon atom, okay, on the right hand side. So we say that maltose is a reducing sugar. So reducing sugars are the sugars that contains free aldehydic group, okay, at the carbon atom 1 of the glucose residue, and moreover they can reduce the Fehling reagent, they can reduce the Tollens reagent, all right. So they are the reducing sugars. So even monosaccharides are mostly they are reducing in nature. Monosaccharides are reducing in nature, but not all the disaccharides they are reducing. So here we can see that the maltose, it contains free aldehydic group. Here the maltose is formed, it contains the free aldehydic group here, hence it is a reducing sugar. All right. So now moving on to the another disaccharide, let us now talk about the sucrose. So sucrose, as we already know, that it is known as stable sugar and it is composed of one residue of glucose and another residue of fructose, okay, and the glucose and fructose, they are together linked by alpha 1,2 linkage. Here you can see carbon atom number 1 of the glucose and carbon atom number 2 of the fructose, okay. So this sucrose, when formed, here you can see it contains no free anomeric carbon atom. It contains no free anomeric carbon atom, okay. So hence this is a non-reducing sugar. This sucrose, it is a non-reducing sugar and its stability towards oxidation make it a suitable molecule. Why suitable molecule? Since it is a stable molecule, so it is used for the storage and transport of energy in the plants, okay. So yes, sucrose is the major intermediate products of photosynthesis in many plants, and the sucrose, it is transported from leaves to the other parts of the plant body. Now there is an important phenomena which the sucrose shows, that is the inversion of sucrose, okay. So usually the sucrose is a dextrorotatory. So what is dextrorotatory? Dextrorotatory are the solutions which can rotate the plane of polarized light towards the right. But we say that sucrose, it is composed of the glucose plus fructose, Okay, now when the sucrose, it will be hydrolyzed further into glucose and fructose. Though sucrose is dextrorotatory, but once it is hydrolyzed, then the glucose remains dextrorotatory, and the fructose, it is levorotatory. And overall, if you see, the fructose levorotatory nature is more strong than that of glucose dextrorotatory. So overall, the mixtures become levorotatory. All right. So after hydrolysis, although the sucrose is dextrorotatory, but after hydrolysis, its mixture, it becomes levorotatory. So this change in the optical rotation from dextrorotatory to levorotatory is called inversion. It is called inversion, and the product mixture, it is known as the invert sugar. Okay, so now moving on to the milk sugar, which is very common, lactose. So lactose is a disaccharide. All right, it contains galactose and glucose residues. So this is the galactose residue and this is the glucose residue, and together they are linked by beta 1,4 linkage. So the linkage is beta 1,4 linkage. Okay, now here in the structure of lactose, you can see that there is free aldehyde group present at the anomeric carbon atom of the lactose molecule. So now uh, glucose residue this glucose residue is available for oxidation. So it is a reducing sugar. It is a reducing sugar. And after hydrolysis of lactose, we get d-galactose and d-glucose. And this lactose, it occurs naturally in milk. Okay. So moving on to the trehalose. So trehalose, it is a disaccharide which is composed of two glucose residues together linked by alpha 1,1 linkage. The linkage is alpha 1,1 linkage. All right. So it is a disaccharide and it is a non-reducing sugar. It is a non-reducing sugar because the anomeric carbon atom is not available for oxidation. Here you can see this is the alpha carbon atom. This is the anomeric carbon atom. So hence we can say that trehalose, it is a non-reducing sugar, and where it is found, it is a major constituent of circulating fluid which is known as hemolymph of insects. And there what it does, it serves as an energy storage compound. So sometimes this trehalose, it is also commercially used as a sweetener. So that's all for today. If you want a lecture on any other topic, please comment down and stay tuned. Thank you.